Today we're going to take a look at percent and unit conversion. Now this material shows up in the book, but it's kind of spread throughout, and I think this is important enough to kind of put it in one area. So I'm just going to cover this separately, and like I said, we'll see it in the book here and there. Alright, so let's start with some percent things. What is 10% of $56? Okay, so what? This is what we're trying to find. So if you were going to write an equation, you might call this x is equal 10%. We're going to take percents and we're going to convert them to decimals. So that's 0.10 of is a word for multiply. So our answer would be 0.10 times 56 is 5.6. Now notice question B is a little bit different here. It says 23.7% of what is 180. So we take the 23.7 and we convert it to a decimal. That's 0.237. Of is a word for multiply. What, there's our x, is 180. So we end up with a simple little equation that we need to solve. In order to solve that equation, we divide both sides by the 0.237. I'm going to grab my calculator here. 180 divided by 0.237. I get, I'm going to round it off here, 759.49. We'll pretend this is money, so it would make sense to round to two decimal places. Okay, well, C and D are for you. Now let's take a look how percents are commonly used here. A person's credit card balance is $1,590. If the person pays off 35% of the balance, what is the new balance? Well, we're starting by owing $1,590 and we're paying off some of it. We're paying off 30% of the balance, but the balance is $1,590. So we're going to have 0.35 times 1590, and again we grab our calculator, we type that in, 1590 minus 0.35 times 1590, we get 1033.50. That's how much the new balance would be. Alright, B, that's for you. A graphing calculator is on sale for $90. This is 20% off the original price. What is the original price? Okay, now I'm going to tell you that many people, even many smart people that I've known, people who have degrees in science and such even, will get this problem wrong. What they'll do, so this is wrong, I'm going to write it in red. What they'll do is they'll take that $90 and they'll multiply it by 20%. 90 times 0.2 is 18, and then they'll take $90 plus $18 and they'll say it's $108. And here's the problem with that. What I did is I added 20% to $90, where what I should be doing is taking 20% off the original price. So let me give you an example of what I mean by that. Let's say the original price was $100. If I were to take 20% off, 20% of $100 is $20. Very easy to figure out. That means the sale price would be $80. So I took 20% off and I got $80. If I add 20% back on, I'm not going to get back to $100 because 20% of $80 is only 16. So I would have 96. So notice when I take 20% of the original price, I get $20. Where when I take 20% of the sale price, I only get $16. 20% off and 20% on are not opposites. Doesn't work that way. Okay, so back to the original problem. What do we need to do? We're looking for the original price. I'm going to call that X. Then I took 20% off the original price. So it's pretty similar to what we did up here in question 2. I'm going to have minus 20% off the original price. And that has to equal the sale price, which is $90. Alright, so watch out for these. Watch these very carefully. If you're looking for the original price, you can't just add the 20% back on. So what do we need to do now? Well, I'm going to think of this as being a 1x right there. And I'm going to combine my x's. 1x minus 0.20x is 0.8x, 0.80x. And so I divide both sides by 0.8. 90 divided by 0.8. That means the original price was $112.50. All right, so D. D is almost exactly the same thing, very, very similar. You're going to take 40% off the normal price, which means you're going to have X minus 0.40X, and then you'll solve that equation. Okay, the last thing we have with percents, I think, is percent increase, percent decrease. To find percent increase or percent decrease, we're going to have a little formula. And the little formula is, you take the original value minus the new value, and you divide by the original value, and then you multiply by 100%. Oh, you know what? I got my top backward. I'm sorry. My top should be new value minus original value. So I'm just going to cheat here a little bit. New value minus original value. Sorry, I wrote that backward. All right, so a house in Corning was assessed at $65,000 a few years ago. Last year, the house was assessed at $90,000. By what percent did the assessment value increase? Well, we take our new value. Our new value is the $90,000. We subtract our original value. The original value was $65,000. And we divide by the original value, $65,000. And then we multiply by 100%. We get 90,000 minus 65,000. We divide by 65,000. And that gives you your answer as a decimal, as you can sort of see there. There we go, 0.38. To write it as a percent, we multiply by 100%. So we would say, let's call it 38.5%. All right. Jared's first exam score was an 87. His second exam score was 71. Find the percent decrease. Well, this is going to be a percent decrease because his score went down. So you're going to work this one out at home. You're going to have your new value minus your original value divided by your original value. And you'll get a negative number because the score went down, and that gives you percent decrease. Okay? So there's a homework problem for you. The next thing we're going to talk about is what's known as unit conversion. For example, I might ask you to take 330 seconds and convert it into minutes. And when I ask that question in a live situation, about half the people will tell me multiply by 60, and about half the people will tell me divide by 60. One of those is the right answer. One of those is very wrong. Here's the proper way to do this. We have 330 seconds. When we get done, we want something that has minutes. Minutes, not minute. I don't know what minute is. Minutes. We're going to multiply by something. And the way to do it is to look at the units. I want to get rid of seconds and have minutes when I get all done. So if I want to get rid of seconds, I'm going to think of this as a fraction. I want seconds down on bottom so that when I multiply, seconds cancel with seconds. And when I get done, I want minutes. So I'm going to put minutes here up on top, and then minutes will be there. And then I fill in the numbers. I know that 1 minute is 60 seconds. So the proper way to do this is called unit analysis. Before you try filling in the numbers, you fill in the units, and the units will tell you if you should be multiplying by 60 or divide by 60. In this case, we see we should divide by 60. I take 330 and divide by 60, I get 5.5 minutes. Alright, let's take a look at part B. Part B is a little bit harder because we have 2 units. In part B, we have 40 feet per second. And when I get all done, I want my answer to have miles per hour. So I have to do 2 things. One is I need to take feet and change it to miles. The second thing I need to do is I need to take seconds and turn it into hours. Let's start with the feet first. Again, I think of this as a fraction. I have feet. I don't want feet when I get all done. So if I have feet on top and I want to get rid of feet, I need to put feet on bottom so that my feet on top will cancel with my feet on bottom. I want miles up on top. I know that there are 5,280 feet in 1 mile. So I put down my units first, and then my units tell me what number goes on top and what number goes on bottom. Now, so I'm half done. Feet reduces with feet, miles is on top. Alright, now let's see, I want to get rid of seconds. Seconds is on bottom, so to get rid of seconds, I need to put seconds on top. Now, for me, it's easier to convert seconds into minutes first. I know that there are 60 seconds in 1 minute, so my seconds reduce with my seconds. Unfortunately, I now have minutes on bottom. I want hours. Well, not a big deal. I simply do it again. If I have minutes on bottom and I want to get rid of minutes, then I need minutes on top, and I put hours on bottom. And I know that there are 60 minutes in 1 hour. So now my minutes cancel with my minutes, and I'm all set. Now I take my calculator, and I'm going to do 40. I'm going to divide by the 5,280. I'm going to multiply by 60. And then I'm going to multiply by 60 again. I'm left with 27.27 repeating forever. So I'm just going to write 27.27 bar. Okay, so these show up in word problems. So let's take a look at problem 5. Horse race lengths are often measured in furlongs, where 8 furlongs is equivalent to 1 mile. A fairly fast horse can run a 9 furlong race in about 1 minute and 45 seconds. Compute the speed of this horse in miles per hour. Okay, so what I know is the horse can do the race in 9 furlongs, takes 1 minute and 45 seconds. Now I think what I want to do, I don't want to write 1 minute and 45 seconds. I think I either want to use all minutes or all seconds. I think I'm going to convert it to all minutes. I know that 45 seconds is 3/4 of a minute, so I'm going to write 1.75 minutes. I think that'll be easier to convert everything to minutes. I could convert it to seconds, that wouldn't be too bad either. Alright, so that's my speed. 9 furlongs takes 1.75 minutes. And when I get all done, I want miles per hour. So it's kind of similar to what we did in part B. We have 2 units we need to change. we need to change furlongs to miles and minutes to hours. Well, let's start with the furlongs first. If I have furlong on top and I don't want furlong when I get done, that means I need to have furlong on bottom. And when I get done, I'd like to have miles left over. And then I look and it says 8 furlongs is equivalent to 1 mile. So 8 furlongs, 1 mile. Furlongs are gone, and I have miles left. Okay, now we repeat with the minutes. So I've got minutes down on bottom. I don't want minutes when I get done, so I need minutes on top. Bottom and top to cancel. And I want hours. And again, I know 60 minutes in 1 hour. Alright, so now I take my calculator, deal with all the numbers. I'm going to take 9 and divide by 1.75. I'm going to take that answer, I'm going to divide it by 8, and then I need to multiply by 60. That's about 38.6 miles per hour. Okay? Alright, I want you to try 6 and 7. Last few problems. In the very near future, we're going to have lots of situations where we're given information and we have to write equations. And students usually have a very difficult time writing equations. That's the hard part of any word problem. Looking at unit analysis can really help to tell if you have the right equation or the wrong equation. So let's take a look at what I mean here. Part-time students at Corning Community College pay a fee of $161 per credit hour in tuition for the fall. They also pay a technology fee of $30 per semester and a student activity fee of $4.75 per credit hour. Let H be the number of credit hours a student is taking in one semester, I suppose, and C be the total cost. Is this equation valid? Yes or no? And what you can do is you can look at units and you can tell. Cost. C is cost. When we get all done, cost, of course, is simply money. So there's my units on C. The number 161. This is $161 per credit hour. Per means divide. So this is money per credit hour. And H, we're multiplying by H. H is the number of credit hours. So notice we have hours on bottom, hours on top. So far we have money equals money. So far we're good. Let's keep going. Plus 30. They pay a technology fee of $30 for the whole semester. So that's a one-time shot. You pay the $30. So that one is just money. It's money per semester, but we're doing one semester, so you only got to pay the $30 once. So far we're good. Money equals money plus money. And then we keep going. The $4.75. $4.75 is money per credit hour. So this is money per credit hour. And now we see this equation is not valid because we have just money on the left. On the right I have money plus money. Money plus money is money. But then I have money per hour. Money can only equal money. All of these would have to be money. What that tells me is to fix this equation, I would have to multiply by hours right there so that the hours cancel out, which means this 4.75 should have also been multiplied by an H. Okay, I hope that makes sense. Give that a shot with number 9. See if that equation is valid. Number 10. A driver fills her 12-gallon gas tank and drives at a constant speed. The car consumes 0.04 gallons per mile. Let G be the number of gallons of gasoline remaining in the tank after she has driven D miles. Determine an equation relating gas and distance and check your equation using unit analysis. Okay, so G equals we want to figure out the number of gallons. G is the number of gallons. So I'm going to start right with units as I go here. So I see the number 12. And what are the units on 12? The driver fills her car's 12-gallon gasoline tank, which means she has 12 gallons of gas. So gallons equals gallons. So far good. Then we have the car consumes 0.04 gallons per mile. So that's a minus because it's consuming, it's going away. 0.04. So minus, the units there were gallons per mile. So my equation is not good. I have gallons here, I have gallons there, but I do not have gallons here. I need to get rid of that mile. So I need to multiply by a mile. Well, what's our thing for miles? Our thing for miles is D miles. Okay, so when we get into this, when we're writing lots of equations, students will be very confused if they should multiply the D by the 12 or multiply the D by the 0.04. If you check your units, there's absolutely no doubt which one it needs to be multiplied. D needs to be multiplied by the one that has gallons per mile so that you can reduce your miles and all your units are gallons, gallons, and gallons. Alright, well, last problem, number 11. You're going to give that one a shot, and you're going to take these problems and you're going to bring them to me at the next class period. See you then.